Hello guys, we're a MISTRAL team. We're working on enhancing network security and analyze it. Our team members is myself, Fahad Al-Adil, and Mshari Al-Saghir, Emmanuel Serrano, and Andy Chen, and Ahmed Al-Ghannam. So what is Mistral? Mistral is a tool that collects data from network sensors, different type of network sensors in a research lab environment, and then filter that by some conditions. After that, we visualize it. Um, Also, I will talk about these sensors. We have two types of those. One is a shallow one, like an overview of what's going on of that flow. Like it gives us some insight about it, like when does the flow started, when does it end, how many packets went through, from where we got this packets or the flow, or from which IP source, and this where it's going. Uh, on the other hand, Zeek sensor does a deep inspection, like what type of connection is that? What the source IP trying to accomplish in that network? And also that data, the Mistral data we are using to feed the AI model to do some assistant. From now on, my colleague Andy will continue from that.
So the way we enhanced Mistral was we created a chatbot that basically compares honeypot traffic with Mistral traffic. And we know that the honeypot traffic is malicious because it comes from Stinger and it's all malicious attempts on those honeypots. So we're comparing the Mistral data to see if there are any like similarities between the known malicious data and the Mistral data so we could see any alerts. And then we're also able to analyze the Mistral traffic data just in general with like the port numbers, IPs, and then hopefully with that we suggest countermeasures based off the alerts. So to make the chatbot, we use two databases. One is Milvus and one is Neo4j. Milvus is a vector database and Neo4j is a graph database. The way Milvus is being used is the user's query or prompt is and the network data, the flows are being converted into vector embeddings using sentence transformers. And then these embeddings capture the semantic meaning of text, which enables the semantic search. So Milvus stores these indexes and these vector embeddings for efficient similarity search. And then the Neo4j database is also being used for user queries as well. So the network data is models that add nodes and relationships between the graph. And the Neo4j captures the structure and connections between the entities, enabling graph-based reasoning and discovery. The way that we search the Neo4j database is through cipher queries, which are used to traverse the relationships and enables efficient context-aware relationship-driven search. And then Mandy will talk about how the AI pipeline kind of works more than that.
Thank you, Andy. So basically I guess like the mastermind behind the chatbot is this AI agent that we implemented. Using Python and various frameworks, we implemented this. So one of the frameworks is called LangChain, and this is relatively new, and it just helps us connect to a variety of AI tools, such as the OpenAI's LLM model, GPT 4.1 that we use through the Duke's AI suite. But we also connect it to Hugging Face, which gives us access to sentence transformers that help us be able to use any sort of prompt through the chatbot and give it to the vector database. And we have all of this connected with API calls using Fast API. And these are just all the technologies used for our agent. I'll then continue how the agent works. So basically, this is the flow of how a query is processed and then implemented. Initially, we have a API server through Fast API that initializes the agent, establishes all the necessary connections through the different databases and also to the large language model that we're using. And a user will then pass a query to the front end, sort of like asking any sort of question about the network that we have through the chatbot. And this query is sent to the fast API backend that we implemented, which then is validated and it's routed to the agent that we have. And this agent classifies the query. Either is it conversational? Is it something that we're going to use the graph for? So like relational? Is it semantic? Are we looking for a similarity? Or is it a prompt that is a hybrid of all of these combined? And after it classifies this, it will send it to basically this function in our backend. They're called retrievers basically, and they're these tools that we implemented that helps the agent pick, okay, which source are we going to use? So let's say for Neo4j, if it classifies it as a graph-based query, it'll generate a cipher query that just converts the prompt from a user into a necessary query that picks the right resource through Neo4j's graph database. So let's say a query is I'm looking for all the flows that are connected to this IP address. So it'll convert that prompt into the necessary cipher query, search that IP address within our graph database, and then output all the necessary flows that we needed. Then after that, it summarizes all this and transforms it back into a sentence, gives it back to the API, and gives it to the front end, and it'll just give us the answer that we're looking for in the chatbot. And here are just some possible questions that you could ask our chatbot. So an example of a like semantic search would be, can you look for a similarity between our honeypot traffic and some MISTRAL flow data that we have? An example of a numerical query would be, how many unique IP addresses are in the data? And something more specific, as I said before, you could just search, show me all the flows from the IP address, and there's the example. And now I'll give it off to Ahmed, who's going to talk about how we implemented our user interface and how we went beyond just the chatbot.
Thank you, Manny. Hello, everyone. I am Ahmed Al-Ghannam. I'll be talking about the user interface. So first, this is the tools that we used for the user interface. We used Next.js, TypeScript, React, and Tailwind. So after we finished the chatbot, we went beyond and made pages for alerts, reports, and visualization. Next are the alerts. So for the alerts, we use an algorithm made by last year Data Plus team that can identify unique ports, and based on that, it's going to send alerts. And the same algorithm makes a p-value from 0 to 1. And based on the p-value, it's going to set the severity of the alert to low, medium, high, or critical. Next is the reports page. The reports page is going to generate reports every 24 hours for any malicious activities that happened in the past day. It's going to give you information about the flow or any alerts that have occurred. Here's an example of the reports. As you can see, it'll give you the total flows, total data, the top traffic sources. Also, it'll give you the risk level, how many critical issues happened in the past day. Also, there is a protocol distribution where it will show you the protocol and how many flows it has. Like the TCP has 89,000, the UDP has 37,000. And next, it can give you the port scanning. It can give you the top IPs and how many ports it scanned. Also, in the end, it can give you a recommendation about what you can do about the issues that happened in the past day. And that'll be it for the reports. Now my friend Mshari will explain the visualizations that we have.
Thank you, Ahmed. And hi, everyone. My part today is to walk you through the visualization system we've made for Levant AI. This is where everything comes together visually to help analysts to detect, understand threat quickly. So we designed 5 core visualizations, each serving different analytical purpose. The first one is going to be the network visualization. So we use D3.js force-directed graph with our graph database to display the network topology in real time. Nodes are color-coded. Malicious nodes are in red. Source hosts are in light blue. Destinations are in orange, and searched IP addresses in yellow. It's fully interactive. You can drag nodes, zoom in and out, and even search by IP address to isolate suspicious activity, for example. The second one is going to be the geolocation map. This shows where threats originate globally, built using React simple maps. It pulls real-time IP location data, even showing if the traffic is coming from, for example, VPN proxy or Tor node. Markers are interactive with pop-ups that give detailed context and severity coloring for the threat levels. And the next one is our the charts. We have bar and pie chart. These offer quick comparisons. For example, showing which ports are must used, and the threats are most common, or which countries are most active. You can switch between the bar, pie, and table views, apply filters, and even view trends over time. Um, Finally, we have the heat maps. The heat map, we use custom heat maps to reveal hidden patterns like hourly threat intensity or IP port activity. They are color scaled to show intensity, which makes spotting anomalies much easier, especially over long ranges. We have also one, but we unfortunately don't have a slide for it, which is the time series analysis. That section uses line and area charts to track metrics over time, like bandwidth usage, network flows, and alerts. It supports different time ranges, like we have 24 hours, 7 days, and 30 days. You can zoom in down to 30 minutes intervals for fine grain analysis. Tooltips let you hover over like any point you get like full metric details. Um, and my friend Manu will go for the video demo for the product.
So users will be able to sign in using their Duke Net IDs, and this is our whole entire application is just made for researchers that will be given this sort of access to. And here's a visualization of how like the security reports work and also the alerts page. That's the example of the report that we generated. All the visualizations are shown as like cards, and then you just pick out the visualization that you search for. This is an example of the network graph. You could search for specific IPs. These are all the bar chart, pie chart. You could even put it as a data table. That's an example of the map. And you could even search for a specific IP address, and it will give you the specific location and what domain and all the necessary information for that. And we would like to just acknowledge and thank all the entirety of Duke Code Plus, the past Mistral team, our team leads, Alexander Merrick, Vanessa Simmons. They have helped us greatly and been a good help, for mentorship and just good resources to go to. The Code Plus directors, Sherry Tibbs, Jen Visas, thank you so much. Code Plus facilitators, they've helped us out greatly, and our stakeholders as well. Thank you guys for listening. And if you guys have any questions, feel free.